Welcome to 3 Steps to Sketch. Today we're going to get the graph of y equals cotangent 3x. I call this a basic cotangent graph because it doesn't have any shifting going on, so no vertical shifts, no horizontal or phase shifts. You can see we're dealing with an equation that's in that general form. Y equals a cotangent bx. Okay, so let's see how we can get this graphed. Okay, here's our outline in the 3 Steps to Sketch method. In the first step, we find our essential information, get organized, get everything ready, so that in step 2, we can easily plot our base cotangent pattern. And in step 3, we'll sketch in the graph and then repeat that pattern over and over again. So we're graphing y equals cotangent 3x. So our first step is to find our essentials. We need to identify a and b here. So a, recall, is the coefficient in front of the cotangent function. Here that's an understood 1. So that's going to help us identify the y-coordinate for our curve setting points in step 2 in that base pattern. B is the coefficient in front of x. So in this case that's 3. So 3, that'll be how many cycles we have between 0 and pi. That's what b tells us. And it also helps us calculate the period. And we know the formula for that for cotangent functions is pi over b. So our period, or the length of one horizontal cycle, will be pi over 3. Now that we have some of those basics, I think we're ready to choose how to label our axes. So how to label each tick mark. I like to do this very intentionally for the horizontal axis because our step 2 base pattern is going to have 4 key components, and it would be really nice for all of our key features to align with our horizontal tick marks. You can choose any scale label you want, but this method makes it really nice and easy, and you get a clean final graph. So for the horizontal scale label, take your period and divide it by 4. Basically, you're taking a cycle and dividing it into 4 equal pieces. So writing that out, we see pi over 3 divided by 4 might be easier to think about as times 1/4. That's the same thing. And we'll label those horizontal tick marks counting by pi over 12. When we label our vertical axis, usually 1 is going to work really well. You can make an adjustment to that if needed, but since a is 1, a 1 for our vertical scale will be great. So let's take a minute now and label our axes so that when we get to graphing, it'll go nice and smoothly. All right, labeling our horizontal tick marks first, we're counting by pi over 12. So count 1 pi over 12, 2 pi over 12 reduces to pi over 6, 3 pi over 12 reduces to pi over 4, 4 pi over 12 reduces to pi over 3. I always like to pause here at the 4th tick mark moving right, just to check that it matches the period, because that's the whole point of this design, is that the period is divided into 4 equal pieces. It matches, so we know we're on the right track, and let's keep labeling. We have 5 pi over 12, 6 pi over 12 reduces to pi over 2, 7 pi over 12, and 8 pi over 12. That reduces to 2 pi over 3. So the negative side of this axis will look exactly the same, just with negatives. So I'm going to pause and label that. Do that if you're working along with me, or if not, we'll meet back with the axes labeled. All right, so this is what that negative side of the horizontal axis should look like. And we'll label together the vertical axis. So it won't take long. We're just counting by ones. So we have 1, 2, 3, and -1, -2, and -3. So now we have our grid all labeled, everything is set up. One more thing before we move on to plotting our base pattern. I like to call this the asymptote generating equation. So it's a way to represent all the asymptotes of the graph in one simple equation. For cotangent graphs, we know that for that parent graph, y equals cotangent x, the first asymptote happens at 0, x equals 0 on the y-axis, and then a new asymptote should happen once a period or once a cycle. So the formula you can use if you're a formula person to find the asymptotes is x equals 0 plus pi over b k, where k is any integer. So depending on which one you substitute in, you'll get a different asymptote along the graph. So our asymptote equation for this particular graph will be x equals 0 plus pi over 3k. So pi over 3 is the period. It happens once a period. Substitute in different values for k if you want to play around with this. It's a great thing to do right now so that you're expecting where your asymptote should fall as you create your graph. If you let k equal 0, your first asymptote is on the y-axis. Let k be 1, of course, simplify that. It's easy. You should have 1 at pi over 3. Let k be 2, there should be 1 at 2 pi over 3, and so on. Negative values as well. It's nice to know where to expect your asymptotes. And now we're ready to graph. So step 2 is to plot the base pattern. So the base pattern for a cotangent graph, recall, is asymptote, curve shaping point, that's kind of your upper one, 0, or x-intercept, and then your kind of lower curve shaping point. Because remember, a cotangent graph roughly looks like this. That's the general shape. So let's go ahead and plot our first cycle of this graph. Starting on the y-axis, we know we have this asymptote here at x equals 0. Our upper curve shaping point will happen at the first horizontal tick mark to the right, so at pi over 12, and you get the y-coordinate simply by looking at a, so 1. All right, then our next point is a 0, so at the second horizontal tick mark, pi over 6, you'll have your x-intercept. And the final piece of the base pattern is your lower curve shaping point. So that happens at the third horizontal tick mark to the right, that's pi over 4. And to get the y-coordinate, you just take the opposite value of a, so negative 1. All right, so this is one cycle of cotangent 3x, and we're ready for step 3. Let's sketch in this actual graph, and then we'll repeat the cycle over again to get a couple more cycles and a nice looking graph. So here is the cotangent curve. Moving right along, we know the asymptote that we're expecting at pi over 3. And let's go ahead and repeat this pattern over again. So moving to the right, we'll start asymptote. Notice it's at pi over 3. That's where we predicted with our asymptote generating equation. Upper curve shaping point, 0. Lower curve shaping point. And then if you want, go ahead and put another asymptote at 2 pi over 3. That's when k is 2 in that asymptote generating equation. Just a nice double check. And we'll sketch in this cotangent curve. A little messy there, that's all right. And let's work our way in the negative direction too. You can either skip 4 tick marks to the right if you like working the pattern just in that forward direction. So we have our asymptote at negative pi over 3, curve shaping point 0, lower curve shaping point, sketch that in. Or you can just work it backward, lower curve shaping point 0, upper curve shaping point, asymptote. You'll figure out what you like best. It's all about personal preference here. All right, and you have another curve for cotangent. So here we have 4 cycles of y equals cotangent 3x. Before we finish up, it is cool to notice that we said b is 3. That means 3 cycles should happen between 0 and pi. Even though this graph doesn't show all the way to pi, I think it's easy to extend and notice that that would be true, because we have 1 cycle between 0 and pi over 3, another cycle going to 2 pi over 3, so to 3 pi over 3, another cycle fits right in there. So that should just really boost your confidence that you have an accurate graph. It's always nice to have these double checks in place. All right, so that's how you use 3 steps to sketch to graph y equals cotangent 3x. Be sure to check the links in the video description. There will be a lot more worked examples, and you can find worked out examples and methods for all the other trig functions as well. Thanks for watching.